Hello guys, in today's tutorial we're going to make a blink for a player. If you recall, we actually made a blink in the previous tutorial, but it was kind of funky and it didn't work very well because the player could clip into walls and whatnot. And in today's tutorial, and maybe in one of the next tutorials, we'll be doing this blink. So I've made this little paint thing. This is the map and this is the player. And if the player is facing this direction, we're going to implement two types of blink. So the first one will be something like, so the player is here, so we want to check if the player can travel until this point over here. So we want to recast a point from here to here, and we want this recast will tell you where it hit something. So player doesn't matter, so the next point it hit is this. So we want to get that point and instantiate the player from here to this point, because there was a wall between the player and the final position. So we're going to put the player in here, and that's the way to do it. And the second way to do it is basically the same thing, is that the direct link. So what we're going to do is check if there's a point over here that isn't colliding with anything, and if it isn't, means that this is free and the player can jump to it. If for reason distance was over here, then it was colliding with something and then the player couldn't blink over there. And if it couldn't blink, it just will go to the nearest point, which was going through here into here. But in the future I want to do something like, for instance, if there is a wall over here and this line over here goes into over here, and if the distance is over here, then if it checks the point over here, and just like it is over here, collide with something, so it can't instantiate the player over there. So instead of just instantiating the player in the first hit point, it will instantiate the player in the last hit point, and that's a bit more difficult because I don't really know how to do that yet, but we'll probably do it in the future tutorial. Anyways, let's get started. So we have our player right here, and to do this I'm going to actually create a new script because all of these scripts are pretty crowded yet already. So new script, blink, and this will be the second blink, so blink 2, create, and let's open it. So the way that this blink will work is if the player presses a certain key, so input dot get key, and we're going to use get key down. You could use get key up as well, but we're going to use this one. Put that get key down, key code, and we're going to use the key L just because, something like this. Okay. And by the way, I'm going to now create the first node where it will just check the closest the player could get to something. So if this is the travel distance, because there's this wall over here, the player would go into here, and that's what we're going to do right now. So all we have to do is to access the physics 2D. So we use the physics 2D dot raycast. There's a bunch of stuff over here. We're going to use the raycast, and as you can see, this is of type raycast hit 2D, and we're going to use that in a moment. So what we want our raycast to be. Let's see. This raycast takes an origin, and the origin will just be the current position of the player, transform dot position. The direction, well, the direction has to be whatever the direction that the player is facing. So for instance, right now the player's local scale is -1, and right now is 1. So for instance, if the player is in this direction over here, facing the right, we want the ray to be to this direction. So what we want to do is to make vector right times this over here, because if this is -1, then we want it to be vector right -1, which will go in that direction, which is the one that we want to travel in this case. So like I was doing, transform local scale dot x times vector 2 dot right, and we can also give it a distance, as you can see, and the distance will be a variable, which will be the travel distance, we can make it like so. And let's create here that variable for a distance, so public float distance. And we can make that variable be, say, 4. We can change it later. Anyways, like I said earlier, this returns a raycast to the hit, so let's make it equal to a raycast to the hit so that we can do some stuff. So raycast 2D, so raycast hit 2D, and we're going to give the name like hit equals this, and now we're going to check some of the properties of hit, and let me show some of the properties. So raycast hit.2D, raycast hit 2D has some properties, and what we're going to do is to check if there's a collider hit. If there isn't, well, then the player can just go to the end position. If there isn't this over here, it goes over there. But if there is, it goes into here. So to check if it hits something, if hit dot collider equals null, meaning if it didn't hit anything, well, I want to transform that position of the player to be equal to over here if it's facing the left, or over here if it's facing the right. So we're going to use this over here, which tells us the direction, so which is a local scale times a vector pointing to the right, times distance to give us the correct distance. Okay, so now if it didn't hit something, it will go over there. Else, if it actually hits something, then we want to transform that position to be equal to the hit dot point. And what the hit point is the first point hit. So that's that. And by the way, there's a thing that we have to change over here, because remember that I told you that this collider here doesn't matter, because if it did matter, then as soon as the raycast was set to go, it would hit in the player itself. But we can change this because Unity has a way to set to ignore this raycast. So just type in the start physics 2D dot raycast, and as you can see over here the description, it says here do rayline casts that start inside a collider that detect those colliders, and this is a bool, and just click on here equals false so that it doesn't detect the player. Save, and right now this should be working, so let's see. So right now I don't know the distance traveled. In a few moments I'll put here a line to display the distance. Anyways, if I tap L, you'll see that it goes somewhere. It doesn't go, and as you can see, it can only travel until the wall, and it goes all the distance. The distance is 4, and if I put here a smaller value like 2, you'll see that it still works. Oh wait, let's see, we made a mistake. So let's see, it's over here. So if it collides with nothing, oh, we forgot here to add a plus, so we want to add to the previous position the new position, and now it will work correctly. So because of compatibility issues, you have to put here, you have to convert this to a vector free. It will be the exact same result. So now you'll see that it works correctly. Okay, even with smaller distances. And I'm going to actually, so like I said, now I'm going to show a line to show wherever we're going to go. So to do that, just put here void on draw gizmos, and first we have to set the color of the gizmos. So gizmos dot color, and we're going to make it blue, and now I want to draw a gizmo. So gizmo dot draw, which will be a line that, and as we could see, this requires two parameters. The initial parameter is the position of the player, and the last parameter is where we want to go, so we put that over here, which is a transform of position plus this over here, like so. Save, and now you'll see a line as soon as this updates. As you can see, now you see a line showing where we're going to go, and if it can't go over there, you just go to the nearest point. This is what we wanted. And now I'm going to put that second functionality where instead of checking array, it first checks a point, and I'm going to put a point instead of a collider because it's simply easier, and so that we can alternate between these two modes. I'm going to put here a variable, so it will be public bool through walls, and if not through walls, then it does this. But if it can go through walls, it will do what we're going to code right now. So we want to check if a certain point, so like I said, we want to check if a certain point is hitting something. So to do that, just put here if physics2d dot, and like I said, instead of a point you can use a box, but it has a bunch more parameters and it can be a bit complicated, and there's also overlap areas which do more or less the same thing. So but we're going to use a point, so overlap point, oh, like so, and this just requests a point, and the point, you may remember, it was this reference on position plus wherever we want to go. So like so, do this equals from here, and this checks if this point is colliding with something, and if it isn't, so put here exclamation point. If it's false, then we just want to do this over here that we did here exactly like that. We forgot the parentheses, like so. So if it's false, we want this to happen. Else, if it isn't false, meaning for instance we go into this point over here, then we want it to go over here. So that's basically doing the raycast thing that we were doing earlier. So just copy all of this into here. So this over here into here, save, and that's basically it. Let's see. In the blink right now the through walls is false. We're going to make it true so that we can actually teleport to the certain point. So the point is over there. If I press L, you see that we go into the point, and that's pretty sweet. And if we go into a wall, like that wall over here, the player will go over here. Probably in a future tutorial we're going to make a player go over here, because this requires a bit more stuff. We're not going to do it now. Anyways, if I press L, as you can see, it goes into here. And that's basically it for today, guys. We didn't make the timer, so we can blink them as much as we want, but I actually made that in a previous blink tutorial, so you can check that out. It's only like 3 minutes long to do that counter, to do the timer. So that's it for today, guys. Thank you for watching, and see you in the next tutorial.